Oh, and I'm talking without a microphone. How nice. Now, let us start. I'm Maria Droujkova. I am a homeschool mom, and I'm a co-founder of Mobius Noodles. Yelena McManaman, the other co-founder, also homeschool, and our kids love mathematics. I have always loved mathematics, and Yelena developed the love watching her son enjoy mathematics. So this parent therapy by play, by open creative play with mathematics, is one big reason we're inviting homeschooling parents to have adventures with us. This July, we interviewed about 40 parents, participants in our open online course for parents and teachers. We asked about their math dreams for the kids. What are your math dreams for your kids? You can type in chat, what do you dream about when it comes to children and mathematics? And you can introduce yourself when you type. I believe that if you dream about it, if you formulate it, you can do it. So parents tell me they dream that their kids will love math, will be creative in it, will use it to solve life's big and little problems, to explore. At the same time, parents worry about big systems of math education, especially early math education. Many systems and establishments simply do not support your dreams. In our book and in our courses, we approach mathematics very playfully, and we start advanced mathematics early. Before I explain why, I want to show you a couple of games from our book Mobius Noodles, Adventurous Math for the Playground Crowd. The first game is called Live Mirrors. You face your kid and pretend you are each other's mirrors. If you smile, your child smiles. If you wave your right hand, your child waves left hand. This is a perfect opportunity to make faces, even stick your tongue out. This game explores the idea of symmetry, a mathematical idea we encounter not just in geometry, but also in algebra and in calculus and in other areas. So we suggest several versions of this game, so you can play even with infants. But can a baby really grasp the mathematics of symmetry? What do you think? Here is another quick game. Okay, look at me on the video. How many fingers did I just show? Did you count? How about now? How about now? I know from studies that you did not have to count. This instant recognition of quantities is called sabotizing. People sabotage all the time without even knowing it. For example, when they play cards or dice. Again, we suggest ways of playing this game with toddlers and even babies in the book. Can babies really do this? Neuroscience and cognitive science tell us that babies can sabotage from birth. Only smaller quantities than we can, up to 3. But since not that many babies play cards or roll dice, should we even support and develop this instant recognition? What do you think? Our key idea is to use subitizing to grow deeper mathematical structures, such as algebra or calculus. Let me ask again. If infants and toddlers really do math, what do you think it means to do math? Humans have been doing math for thousands of years, but we do not yet have the universal definition of what mathematics is. What do you think it is? Do ask the kids when you have a chance. I define math as finding patterns, posing problems about patterns, and sharing solutions with other people. So math is patterns, problems, and communication. We, the adults, rely on speech and writing to communicate. We also have all sorts of math stuff, symbols, graphs, tables, and so on to help us communicate. What about babies? What about young kids? Suppose, as the research shows, babies notice math patterns, pose and solve math problems. How can they communicate math without writing or even talking? How can we help children to share the math they do? Consider all the things a baby can do. Look at something, grab, point, make faces, and move around. Toddlers can do much more. So we can play games that help babies communicate deeper math ideas. Live mirrors is one example. It gives toddlers a way to analyze rotations, reflections, and axes of symmetry. Should we do algebra with babies? What do you think? Type something in chat if you have ideas about it. My answer, as you have guessed, is yes. And here is why. Some ideas are universal across cultures. When it comes to mathematics, all cultures use some patterns, some quantities, some geometric shapes. But other mathematics is very rare. Algebra is not universal and rare even within the technological societies. For example, only 5% of adults in the United States are currently fluent in algebra. But our technology is built on deep understanding of this advanced math and relies on people who are fluent in this math. Think about it. How do we get to that level of understanding, of deep understanding of algebra? How do some of us become fluent in advanced mathematics? What do you think? I think it works the same way we become fluent in our native languages. Since before birth, we have been immersed in rich and lovely natural language. You don't wait until the baby recites the alphabet. You always sing, you talk, you read to the baby. And the first step to fluent algebra is also immersion. You always have lots of beautiful algebra activities all around. The second step is giving kids algebra toys and games that help them to communicate mathematics. Let us look at more ways you can strew math all around and more games. We have more examples of games in our book. Babies love well-organized structures, such as fractals or checkered patterns. Even simple grids about shapes and colors are fun to a kid for a while. How can kids communicate about these grids? Here is an a more involved grid examples with made-up animals. A baby can smile when you put animals into their right places. If you mess up, the baby will probably laugh at you. From the surprise, toddlers can sort toys on a grid all by themselves. Can you feel the missing cells? Kids around 5 can play the grid games with words or abstract pictures, and later in spreadsheets with symbols. So this grid activity is an example of developing an algebraic structure from baby games to spreadsheets. That's how you do it. You start very concretely with pictures, and then you go to more abstract ideas. Here is another game, and most of you, I'm sure, have played it as a memory game. But you can also play it as an algebra game, Find X. You set a few toys in front of a child, and after a few seconds, you ask the child to close their eyes. Then remove one of the toys, tell the kid to look, and guess which toy was removed. You can play it during story time by covering one of the pictures, as I've done right here on the slide. You can play it with food, with anything. How will babies and little kids communicate about their lost X? A baby will know which favorite toy is missing and smile when the right one comes back. Toddlers can solve Find X puzzles with toys in small quantities that they can sabotage, that is instantly recognized. Older kids can play this game with words or pictures and then with symbols. Again, this activity develops the algebraic structure of equations from hide and seek with toys all the way to the formulas. Why? My favorite question, the most important question in mathematics. So, young kids can do pretty adventurous math, and we can enjoy it with them. And in the long run, they develop deep understanding and love of math that helps with careers and life in general, and with deep questions of life, the universe, and everything. What is the problem then? This is a rather fresh last week quote from Glenn Whitney. He's the founder of More Math, the Museum of Mathematics in New York. As homeschoolers, I think we are in a unique situation. We have the power, and we have the power to change things for our kids. And we can use that power and our freedom to explore lovable math, playful math, deep math. We can be brave about our dreams. And we can ask big, important questions about learning mathematics. These ideas that I have on the screen right now come from parents in Möbius Noodle circles. You can adapt pretty much any math for young kids. Think about it, any math. Think of it as a do-it-yourself DIY experiment or a maker task. You make your own math with your kids, for your kids. You use toys, you tell stories, role play. You let your children be heroes in their own mathematical adventures. You can connect advanced math to the joys and the deep interests of your own children. You can include math in daily activities, play dates, trips, games. There are many casual math activities you can do everywhere. At lunch, at the park, visiting a museum, playing with friends. Just add a bit of math play to all aspects of your life. We started building a collection of these activities on our Facebook page, and we use these hashtags when we share ideas. And we are building a better organized knowledge hub as well. Here are more tags we use when we share resources. You can add math to your story time. Go beyond counting books to infinity and beyond. Dimensions, functions, network, algorithms, there are books about all that. Excellent math stories you can read to your kids. Here is Julie Brennan from Living Math site on the picture, surrounded by all the books she reviewed. There are big lists there. You have your math apps. Prepare a few for when your kids want to play with your smartphone, or have some on your computer. When they climb into your lap, you can show good things. We call it lapware. You can collect short math videos on YouTube, show to your children. There are a lot of things. With math minutes, tell your kid, we play with math. We think math is beautiful and fun. We love to share our math. The fractal pictures, they become from an app called Geometry. It's a free app, and there are a lot of beautiful free apps out there, and of course free software for PC. So there are better resources than definitely 20 years ago, but even 5 years ago. You can make very beautiful math for your kids. So what next? If you don't know where to start, you can try some things from our book. It's Creative Commons. It's created with homeschool parents, by homeschool parents, for homeschool parents. It's available online. We put ideas on our Facebook page every day and then have a newsletter. So all these activities take just a minute a day, require no preparation. And you can add short math games to your next play date, like a live mirror game that I described. You can connect with other parents and educators and ask questions. You can take online courses. Our next one comes in September, and we would love to see your questions and comments by email anytime. And that's all the talking head I have for today. So now we can do questions and answers here. Thank you. You can type your question in the chat, or you can get a microphone and ask in voice. Any way you would like to ask. I see somebody is typing, so we can answer that anytime. Yes, let's give people microphone privileges. You can raise your hand if you'd like to talk with the microphone. Click the little hand or button over the list of participants. And if you have that, I'll give you the microphone, or you can type the question in chat.
I was just going to jump in for just a second. Okay, it's back. Never mind.
Did the voice disappear for a while? Some of the things that it really helps to do while we're waiting for questions is to get just a few parents together and to have a little math circle. So that's something where you play together and do whatever your kids want to do, but with mathematics. Hannah has a question. What are the ages your book is aimed at? This is a bit tricky, actually. We say it's for babies, toddlers, and young children. Now, some people report very good results because the games are very hands-on and they are oriented to arts and to storytelling. what people say is that older kids just adapt the tasks to their level because they can storytell, they can play. So people have done these things with kids from anywhere from babies really to kids who are in their teens. But the second thing we hear, Hannah, is that parents say, oh, now I get it. Now I enjoy the math. I see this. I've never looked at it this way before. So grown-ups really enjoy it. And it's not just people who maybe had some difficulties with math. It's people who have, I don't know, PhDs in science fields tell us, oh, I never thought of multiplication this way. I've never thought of fractals from this point of view. So it's really multi-age there. That's the whole point. You can do things at different ages and mixed ages. Does it answer your question? Okay. If you're interested in mixed age activities, I recommend Peter Gray's presentation that will come up later. He is a big proponent of mixed age learning, and he has very good points about why it's important and why people learn better in mixed group environments. Of course, if the environment is set up for that. Iris, this is a very good and very important question. Now, I've read and I talked with people about, well, paralyzed kids who are very sharp in mathematics and very talented and learn mathematics powerfully in their own way. So one thing to do is to follow the gaze of the child, so you can set up things far to the left, far to the right, and do the choice tasks and sorting tasks. Just follow where the child is looking with the eyes. And it's the same as pointing. If the child can point, you can point for the child, and the child can point with the gaze. I would also look into the software that now exists that can read brainwaves and can understand simple commands, like, again, directional commands, left and right, but also typing commands and more complex. You can train the software. And I don't know what your thoughts are on early software. I am a big proponent of using computer tools with kids, of course, in healthy ways. And so this can be a big help, where you can set up some baby games on a screen with the software that reads the brain waves. If your child has any motion at all, like small motion, you can again use some interfaces for computer that enable in the interfaces with that. But a lot of visuals, a lot of visualization too, and sound. A lot of people learn mathematical patterns through the music, and if your child's hearing is not impaired, you can learn beautiful, beautiful things with the sounds and through the sound patterns. Sine waves in music, the crab canon that plays backwards the same as the forward by Bach, just sound patterns connected to the visuals, that sort of thing. Does it make sense, Iris? I would also seek other parents who are technologically advanced, and that would be a very good question to pose to our Ask Forum Ask and Tell forum, so parents can chime in with the tools they've developed or found for that sort of thing. Because, of course, people who have been on this board would know more and would have researched more, maybe people with older kids. Very good question. I love the, while I'm waiting for questions and comments, I love the internet for how parents with, well, less mainstream and niche requirements can find other like-minded parents who have similar ideas and similar concerns, and then share resources, just band together, and one person finds one thing, another person finds another. Now we together know much more than any one of us. It's the same actually for different types of people, for different sub-communities. Well, it helps the homeschoolers too. Debbie, can you talk about your mixed age group a bit? You mentioned you have a multi-age homeschool class. How does it work?
Yeah, I do. I was a certified teacher before I decided to homeschool, and so currently I'm teaching a Thomas Jefferson education course to children 9 to 13, and I'm actually doing 2 classes with them, an ancient civilizations class and a life science class. And what I love about it is it focuses on the love of learner, so all of the activities are very hands-on based, simulations, and the discussions that come out of it, because it's not just sitting at a desk and listening to a lecture, it's experiencing. So if it's ancient civilizations, then we might be the Egyptian societies and someone's the pharaoh and someone is this class, and how do they interact, and having these activities that they do to experience what it was like in those sort of time periods.
So what do you see younger kids contribute and older kids contribute when you do it with mixed ages?
I find that the older children really support the younger children, like they have a better understanding of the deeper ideas. But the younger children, they're just so engaged in the fact that they are experiencing another culture. But you find that the level of conversation of the younger children, they bring questions that the older students would not have thought of because they're coming at it from a different point of view. But what I love about I always love having younger kids in my class because of the mentoring that goes on from the older students to the younger students. And their grasp of concepts is so much greater than we ever thought of when it's introduced at a younger age. And that, I think, is what I love the most, is to see them say, well, wait a minute, like they'll look at, like say they'll compare it to their dog. Well, wait a minute. When I tell my dog to sit, he sits. So are you saying that these people in the Egyptian culture, they weren't allowed to like go in this room? They had to sit and stay outside and they couldn't come in? And you're seeing them make these connections to other sort of examples that they see in their life.
This is a great point about connections. And one of the great things that I love about young kids in math too, because they bring up such good, unexpected, totally out there examples and connections, and at first you are taken aback. Well, what's about it? But it makes sense. So go ahead, Grace. Are you trying to speak? Maybe not. So, this is a big point. Where are people here from? I'm just curious. There are homeschoolers all around the world, and there are several people here. So where are you all from? I live in Cary, North Carolina. It's in the east part of the U.S. Baby's in Los Angeles, South Carolina. So I think we need to Northern California, Oklahoma. Anyone outside of the U.S.? It's interesting that mathematics seems very international, but what I found is not all communities equally appreciate early advanced mathematics. So in the US in particular, I found that people who are in technology startups, programmers, university people in high-tech fields, these people really appreciate mathematics for young kids, advanced math. So when I say algebra for 3-year-olds, people understand it. But not everybody agrees, and there is some controversial stuff there. Mathematics is their native tongue. That's right. And what I found is that in the US, immigrants from certain countries, again, are more appreciative of early advanced math in particular. So I can name India, Asian countries, Eastern Europe. And then it really depends on the particular person. The hardest thing is for people when they don't have any friends who like math. So the best thing to do then is to find some people and to start finding what you love. Just something to do, a little math circles with friends. Hi, Sian, do you have a microphone? Would you like to talk about the native tongue thing? You just press the talk button.
I could a little bit. I reflected the same thing. There's a lot of technology people, and our children ask us about things that we use, and the same as any other household. In fact, many of the immigrant families were here because of they're working in technical jobs. So our children have technology and technological language as what they can ask questions with. So I don't know that other kids aren't interested, but ours just to have the language.
This is a very good point, and I talked about it a little bit when I talked about communication, how can young kids communicate. So yeah, I am yet to see a kid who was not interested, but I've met parents who weren't, or families who couldn't start talking about it, basically. That's the issue. So yes, and text language, the language of programming, the language of computers, the language of science kind of lends itself. So yeah, the family has some of that there. So for example, this picture is a function machine. And of course, you see function machines in computers all the time, or you see functions in any science. So anyone who's fluent in that would talk with their kids in some ways. Yes, exactly, systems and patterns, and it leads to mathematics. So that's actually a big problem because all kids are interested, but not all parents are. And how do we get there? That's a big question to ponder. Another big, so you can ask any question. Groundworks. Let me try and, do you want to bring it up on a web tour, Debbie? while I'm talking about the things. So there are several resources we can share like this. Groundworks, visual problems, it's a way to invite kids to do the well, some tinkering basically. But why is visual important here? Unless you're visually impaired, it's more accessible to young children. It doesn't require symbols, it doesn't require words, so it does something that children are born with. And that's one of the adaptations. For some reason, the web tour is not coming up for me. Yeah, bring up the resource, please, but the web tour is not coming. Oh, here it comes. No, why not? Okay, like this. No, that's not it. Okay. I grabbed the web tour. Don't forget to do the follow me after you find it. But there are several resources online in particular that I really like. Computer Science Unplugged is another one of games and problems. I'm going to show it now. Ooh. As soon as I make this web tour working. There are a lot of things that came up. Okay. Tools. So there are quite a few programs now that you can start. You can find for different ways, for different styles. Dragonbox is a very interesting toy. It's a game that, well, a toy, I would say. It's not quite a math game, but it shows mathematical equations in very accessible ways, very visual again. So it's the same principles we have for adapting to young kids. You tell a story, and Dragonbox is a story about balancing some dragons. You, oh, thank you, Debbie, for the link. You use bright, large objects. You do some pretend play, and you, of course, use small numbers or no numbers at all. In fact, you just use dragons to represent ideas of measures. So it has all these check marks of what a good adaptation for young kids does. And there are other there are a few other good games like this, but not as many as I would like to see. So if you are interested in game development, we should talk about building some things. We are actually talking to several people about making Möbius Noodles games into apps. We had a grant from National Science Foundation a few years ago to build some prototypes, so we have some good prototypes already. Maybe they just issued the new set of levels actually a few weeks ago. Check it out. Katia, can you talk about your teams?
Well, I just have kids that I work with. I work in a learning setting where kids learn from people who love things, and I happen to love math, among other things. And so kids that aren't in a family that has somebody like me, their kids come play with me. and I'm always looking for interesting projects and other adults for them to work with.
Excellent. Let us talk more about it. We work with interns, and we've been working with interns all the time in good ways and helping them learn things, helping them learn the ropes. We had teen interns do art, writing, game design, everything. So let's talk about connecting with your project. The next adventure we will be having at Möbius Noodles is early calculus. So we've done some early algebra games, and now we are collecting ideas for doing calculus with 5-year-olds. Well, not really. We're doing games inspired by calculus. And the teens are perfect for that because they are just starting to explore it in a more formal way, typically when they when they go into the fields. So they are either excited or scared, but they have feelings about it, and doing it in a way that a 5-year-old can understand, I think, can be interesting for them. So let's talk after this. My contact information is here. Möbius Noodles is our mascot, but I get Möbius email too. Actually, I was just involved in a project in India, in New Delhi, that they had groups of teens design the city of the future using mathematics and architecture. So that was a pretty interesting project for older kids. And last year we did a project for science and math for doing called Saving Oceans Together. So we did some crochet and paper modeling of coral reefs. And the kids went to St. John's Island in the Caribbean to look at the ecosystem after they've done a lot of research and designed a card game. So that was an interesting local project here in North Carolina. I just want a show of hands while I'm here. You see, you can, there is a checkbox over, the list of names, and it allows you to say yes or no. So I'm asking a question about calculus, and just answer yes or no. Do you think calculus is appropriate for 5-year-olds? Yes or no? Try and use that checkbox. I see some yeses in this room. Do we have a no? Argarsi, wanna try your microphone again? Try to speak right now. If you wanted to talk, that is. But so 4 people said yes so far. We don't have any no's. There is a talk button too, but when I asked this question in a LinkedIn group, we had a big discussion with a lot of people saying it's not appropriate to kids to do advanced math because they have to play. And it was sad to me that people say math is not play. That you can either do math or play, but not both. And I believe mathematics is a very good form of play, and advanced mathematics in particular encourages people to play. what are some difficulties you are having homeschooling with math? Are there unschoolers here in this room? Some people say it's hard to unschool math. Well, Valosia, would you like to talk about your math? Do you have a microphone? I would say, as a parent, I was okay. I was more in. My kid is grown now, so. But I would say we're more unschooled than anything. But we did a lot of work and work-oriented activities. The difficulty is that, well, for me, the difficulty was that math is kind of invisible in grown-up world, hidden from children, not very child-friendly. So we had to do some adaptations, and I wonder if it's the same reason that keeps a lot of grown-ups from using math, because it's not friendly. Yeah, we need to do mobile here, trying to debug. Cassian is sharing about parents who weren't good at math. There is a lot of pain there. Last month, Yelena and I did a presentation at the local science cafe. So the science cafe is when scientists who do interesting research come on stage and talk about their studies or studies in their field. We started to talk, and I love science cafes, but when we ask people to ask us questions, usually people ask about scientific discoveries or new science things. In math, people took microphones and said, oh, and listen to what happened to me in 3rd grade. Listen, I had this horrible teacher. Oh, when it was about fractions, it really was painful for me. And then algebra started, and then I lost it. And most people even forgot to ask any questions. They just wanted to share their stories of how they got hurt. So yeah, feeling parents are not good at math is a big thing. You almost need some sort of therapy. That's one reason we use very bright pictures and short activities and keep telling people, find what you love, find what you like, find your comfort. So Miranda has an interesting question there. They do not enjoy writing math, but like talking and playing. How about computer models, Miranda? So, for example, if you use Wolfram Alpha or a grapher or spreadsheet even, or those pretty things that make beautiful pictures, do the kids interface with those? Do they put in variables? Would they type? Or would they drag little sliders? Can you talk about it some more? Do you have a microphone? Yeah. I am going to try and share my screen with something called WeaveSilk. It's a geometric interface for, you can have it on computer or you can have it on mobile device. Yes, so let me try and share it here. I don't know if it works in the web tour. I will try my best. If it comes up. Okay, so it comes, you can click right here and play with it. You can draw something. So, can you? No, you can't, not in here. I'm going to put the link here. And yes, I'll have to do application sharing instead. So let's see. I am going to share my Google Chrome, and I'm going to draw here, and you will see my drawing. Okay, so I stopped application sharing, and I hope you saw some of it. But Miranda, the point is, it creates mathematics, and it's a form of recording. You can save it, you can share it. I can see someone talking. Oh, that's our Garci trying to get the microphone to work. Right. So, but it's very accessible to young kids. I played with stuff like that with 1-year-olds, with younger kids. They just use their finger on the touch screen. It saves, so it can help your kids communicate without having to write it down necessarily. And another trick for very young kids is to make, well, little movies. So you can point a camera at them or a webcam. You can make a screencast, and they can just show their things and talk. They need to record it. The approach that's very homeschool friendly is, and that talk a lot about how to help young children capture their work, is Reggio Emilia, and they have a book called 1,000 Languages of Children that talks specifically about capturing young children's work. So I really like this approach, and you can use pictures, video, you can help them record their stories. They will write things if they have interesting things to write, and yes, 7 is very young, but they still like to capture. Give them a camera, they can take pictures of their work. That's a lot. They all appreciate documentation, but maybe not writing. Okay, let us finish at this, so you have some 5 minutes before the next session. Thank you very much for coming. Please write me or contact us on online and other forum at Möbius Noodles, and I'm looking forward to playing more with teens, with kids, with parents, and doing math adventures together. Thank you.